This sheet is studying the relationship between how the length of a wave and really the length of the string. So if you take any of these, what we call a standing wave here, let's look at F. F, this would be one complete cycle. Okay, this is one complete cycle. We say that's one wavelength. Here would be one complete cycle. Okay, down here, this would be one complete cycle. Complete cycle like this. Here, this little tiny guy, this would be one complete cycle. And so what we're given the speed of a wave, okay, the speed of the wave, we'll come back to that later. But if you look down here in this table, for example, in A, it says the length of the string is 25. So we know that this distance is 25. But look at how many cycles there are. There's 1, 2 and a half. There's 2 and a half. So if there are 2 and a half cycles in 25, okay, and then you can see here on this second sheet, if there are 2 and a half cycles and the length of the string is 25, then we can just take the 25 divided by the 2 and a half, and that will give us 10. Now, if you look at wave B, okay, if you look at wave B here, with wave B, this has a length of 28, and there is 1, 2, 3 and a half. So if you look at that 1, 2, 3 and a half, and then 3 and a half, how long is one of them if 3 and a half have a length of 28? So again, if you look at this sheet, the length is 28, but there are 3 and a half cycles. That means each one has to be 8 centimeters long. So if you look at any one of these, you can take the string length and divide by how many cycles there are. So here would be 1 and a half. Here there is 1, 2 and a half. Okay, so in letter C, in the length of that string, there would be 1 and a half. In letter D, there are 2 complete cycles. Okay. Now the amplitude is the distance from equilibrium. So this is the amplitude. We normally don't, well, we can say that the amplitude is here, but amplitude is always a positive number. So if you say it goes down here 5, then we would say that the amplitude is 5. And that's really what it's talking about down here. Okay, now let's look at the second relationship. Coming back here to this, the speed of the wave is 42 centimeters per second. Okay, so there is a formula that is given, and its velocity. Here it is, right here. Velocity is frequency times wavelength. This symbol is lambda, and we usually use that for the wavelength. So the velocity is the frequency times the wavelength. Now, the velocity was 42 centimeters per second, okay? And that's for all of those waves. So if we made a table of values here for the velocity and the frequency and the wavelength, let's say the frequency is 1, okay? Frequency is 1. Then the wavelength would be 42, because we have the formula velocity equals frequency times wavelength. Okay, so notice that if we multiply the frequency times the wavelength, we will get that velocity of 42. And in the problem that you were given, all of those waves had a velocity of 42. So let's look at some other values that might work. If this is 2, then the wavelength would be 21. 2 times 21 gives you 42. All right, let's take 6 times 7, or 7 times 6, or 21 times 2, or 42 times 1. Okay, notice what's happening here is that as the frequency gets bigger, the wavelength is getting smaller, right? We say that's an inverse variation. So sometimes I'll do it this way. Velocity is constant. If you have a small frequency, then you're going to have a large wavelength. If you have a large frequency, then to balance that, you would have a small wavelength. And so what they say down here is which of the following are true for the frequencies? Okay, are the frequencies? Well, notice that the largest frequency corresponds to the smallest wavelength. So here the smallest wavelength is 8, and so that means that B would have the largest frequency. And so when you list them, that's why B is the biggest. A and E, okay, A and E, 10 and 10, these have the same wavelengths, so their frequencies would be the same. In this case, since it's 42, the frequency would be 4.2. Okay, so hopefully that helps a little bit with this sheet. Okay.